Welcome viewers. Today I welcome you back in class 9 classes. These class 9 classes are on force and laws of motion. We have some videos already uploaded. Started like this. We did force, after that first law of motion, second law of motion, their applications, and then the numericals also. After that we are remained with the third law that we are going to do this. Of course, this is the name of the chapter in MBSc, chapter 2 science. Okay, the new topic is Newton's third law of motion. How many laws were there? There were 3 laws. Third law, it is simpler in its statement and pretty useful when we understand the applications also. Let us see what is this. I'll write the statement in its simplest form. It is given here like this. Every action, remember action means force, has an equal and opposite reaction. It is very easy to remember. Two things, action and reaction, both are force. Okay, to every force there is another force. It's pairing force. We call this as mirror twins also. Okay, there is a name given, mirror twins. So what does it mean? Is whenever you exert or put any force on anything, the same amount of force will be put back by that object to the in the opposite direction as well. This is called, to every action there is equal and opposite reaction. So that we will quickly think, whenever this is statement is given, we tend to think, we used to think that then why the object is able to move. If I am pushing this also pushing me, then it should never move. But we have seen things are moving. So why does this happen? The second part is very important. To every action there is equal and opposite reaction, but these two forces may not act in the same object, on the same object. Okay, so that is why it is possible that the outcome is a motion. Otherwise the line of action may not be same. So that is why the object is able to move. Okay, they don't cancel each and every time, right? Let us see by giving an example of, if an object A pushes, pushes means push, or pulls B, another object, then the explanation of this thing, then at the same, this is important, same time, simultaneously together. Okay, same time. You cannot say which one is before, reaction first or action first. You cannot say that. You can say this one is the reaction, this one is the action. You can say this is the action, this is the reaction. Both are interusable. Okay, time. At the same time, what happens? Object B pushes or pulls A. This is the meaning of this statement. Okay, now we can understand with many examples. The most common example is an athlete running. I'm not very good in drawing. Let me draw as simple as possible. This is the ground on which this person is going to run here. Okay, in this direction is planning to run. Now we have to look at his feet. Its feet. Okay, look at here. What he does is, whenever he is moving this direction, where from the force comes, he is applying force in this direction. Okay, this is called action. Now in the same way, there is reaction in this direction. Action and reaction. Can you see the opposite direction of this? Now what happens here, if I draw the diagram, it will be very complicated. I will not draw this. The body is acting downward like this. Body's weight is downside, the force is downside. Okay, so the normal is acting in this direction. Okay, so here force is acting this way, I'm drawing it here. Suppose there's a weight and this reaction is here, right? Now this reaction is this one, okay? This reaction has two components, this side and this side. This part will cancel the weight because they are exactly opposite in the same line, but there remains something in this direction which is making the body to move this direction, okay? Because you have to think only up to this much here, that because of this action you are able to move in this direction, the outcome of this reaction, okay? The body A is the object, the person, athlete. Body B is the ground. A is exerting a force A on action here. The ground is exerting the force B on the opposite direction. This is the first one which is given in the textbook, okay? Now another example given in the textbook is this. A person is here, rope is tied here in their hand, and another person here, they are pulling the ropes together, okay? This, his name is A, his name is B. If they are pulling each other, now we can call it FAB is the action. You can understand what is FAB here. Force on A. The first one is on A due to B, and FBA is what? Reaction. This way also you can write. Force on B. This is coming first, so I'm writing first. You can write anywhere, okay? There is no hard and fast rule. This is the action which is applied by A. Force on A due to B, okay? A force on B due to A. So these are the symbolic form of writing this FAB and FBA. Now this third law says that this FAB will be exactly equal to FBA. This is the meaning of third law, okay? Not many statements are going to come here. There are applications. We'll discuss that. Practical applications of, just like first law and second law also we had applications, here also we'll have applications of third law. We are in page number 42. The first example, when a batsman hit a ball, the bat exerts a force on the ball action, and the bat exerts an equal and opposite force on the ball exerts the equal and opposite force on the bat. Bat exerts action on ball and ball exerts reaction. So easy on bat. So easy, isn't it? When you are playing any game, other than cricket also you can play basketball, tennis, whatever it is. The bat is exerting force on the ball, that is action. The ball is in return at the same time hitting the bat with the reaction force. Number 2, if you push against a wall, if we push against wall having smooth floor, imagine that you are standing here and the floor is very smooth, okay, and there is a wall here, big wall. If you push this wall Okay, what will happen? Your feet will be dragged back this way. Wall having smooth floor, what will happen? We slide which direction? You push that direction, we slide this direction. We slide backward. Okay, very easy to write. Just maybe 1 marks they will ask, and you can quickly make this without drawing the diagram. Also, you can write when we push something. This happens very easily. You can understand when you push very heavy object or feet, you will feel very easily it is going backward. Okay, this is the second example given. We go discussing some more examples also. There comes my favorite example, which is easy to understand also. After few of them, it is, I'm sure it is in the book also. Number 3, when you walk on the ground, you push the ground in the backward direction. The ground exerts an equal and opposite force R on you, and the component of this force along the horizontal direction makes you move forward. This is already discussed here, but I'll write here. On walking, the reaction of action results into horizontal component responsible for movement forward. Okay, let me try to make you this understand. We have already done in the first one that while writing in the beginning. When you walk, what happens? You are giving the action here. I'll write A and R. The reaction here. Okay. Now, how they balance? You have the weight downward. Now this reaction has 2 components, this way and this way. Why they are having component? Because vectors have components. Okay, vectors have direction property and they get components. Of course, you have not done it up to class 9, so in class 11 you will do more properly and very easy to understand. Without class 11 also you can understand. This is a direction dependent force, so it has 2 components. This side some effect, this side some effect. Okay, and this side it is horizontal component. This side you can call it vertical component. So in the book also it is written H, horizontal. Horizontal means this direction, X direction. Vertical means Y direction. Now look at here. This weight is balanced by this vertical component. But to balance the horizontal, there is nothing here. That means here the reaction is giving full force in this direction. Net resulting in this direction. That means what will happen? The body can move now. This body will move in this direction. That is what we call walking when we walk in this direction. Okay, so this is the meaning. I will later on also may use this same thing in other chapters to make you proceed from here. Okay, some more examples are there. 4, yes. It's also common in the schools. It can be done very easily if you have this simple thing. This is called spring balance. If you have seen, I don't know, you may have seen this or you may not have seen. The person is carrying this. Okay, spring balance is something which you can weigh things, okay, measure things. How many kgs mass? 2 kg, 3 kg you can measure. Here there are 2 things attached here together and it is a wall. On the wall you are putting, you are pulling it from this direction. What will happen here? This is S1, this is S2, spring 1, spring 2. Now you look at here, if you are pulling this with 5 Newton force, okay, here you will see the reading is 5 reading you will see. And at that time, if you ask someone to observe here, you'll also find here 5 is coming. That means what? If S1 is pulling the S2 with a force of 5 Newton, the S2 will also pull the S1 with 5 Newton. This is a clear indication that action and reaction are there in real. Okay, so here two springs, spring balances pull each other with same force. Why they are having in the same same line? Because there is a wire attached to them and they are pulling each other, and you can see whatever force here, same will be on the other side. Okay. You need your textbook with you so that we do not go anywhere else from the syllabus. Mostly I will concentrate what it is in your textbook, okay, so that you will see the textbook. It will be very easy to understand. While firing gun, the soldier feels backward recoil. What does this mean? I'm not very good in drawing the pistol and all. Still I'll try. Suppose you have a pistol like this. Okay. Okay. Look at here. What you do is, whenever you are doing this fire, okay, from a bullet gun, you can have big gun or a small gun, it doesn't matter. When you do this, some chemical reaction will happen inside, means something will burn, whatever it will happen, and the bullet will be fired from here. This is action. Okay. At the moment, same time, when this happens, there will be a recoil. Means whenever somebody is shooting, there will be recoil. You must have seen in movies, somebody is shooting, the soldier is shooting and getting a backward coil this way. Okay, so this is that. So this is the reaction. This also coil, it is also called recoil. Recoil, why? Because in the soldier language, in the pistol language, in the bullet language, we call it recoil, but in physics language, it is action. This is a reaction. Okay, in short, how we write? While firing a gun, the soldier feels backward recoil. Why? This is because of third law of motion. That's all. Now, this is my favorite example. I don't know I'll be able to make this or not. When we jump out of the boat, the boat is pushed backward. Okay, the boat, not a great diagram. Okay, so suppose this is the person inside the boat. Okay, inside this boat he's going in the water. After some time he decided to jump out of the water. When he is jumping out, okay, when he is jumping out of the boat, when he is jumping out of the boat, okay, what will happen? When he is just about to jump, or he has just came out of the boat in the water, you'll see that he is coming in this direction, action, force. The boat will be going away. This you must have experienced, even a small swimming pool with something on which you are using it. Okay, anywhere in the water you try to come out of this, you'll see the boat will go. So this is a classic example of action and reaction force. Okay, so this diagram you can write, or in just 1 marks you can explain. When we jump out of the boat in the water, the boat is pushed backward in the water. This way we have seen many examples, 6 to 7 examples of where these things are happening. Okay, most important to understand is still motion is happening. Why? The reaction and action are not acting on the same object. Okay, this action is by this, reaction is by this, so it is acting on the water. So that is why the water is receiving the backward coil, okay, going away. That's it. So this way things are happening. Action and reaction are still possible to move. There is activity 2.1 and 2.2 in the textbook. Again, to demonstrate in the classroom atmosphere, you can see some already prepared YouTube videos to understand them more classically. These examples are used in many videos, but I'll try to do this. Activity 2.1, only the meaning I'll try to tell you. Activities are important now these days. Activity 2.1 is going to tell you how this setup is this, like this. I'll not write the detail, only few lines are there. You have a test tube, okay, it is tied here, tied with a rope, small rope, maybe thread, and there is a cork here. Cork means just tight, but it can come out. If you pull, it will come out. It's just tight. Okay, and what will happen? Burner, this is tube, cork means cover, burner, body. So what you do is you fill water here inside the tube. Okay, don't touch it, let it hang like this. This is a stand, here I am hanging it. Now burner, fire. What will happen is, after some time, when the water inside the tube will get heated by this, and then some gas will be coming out of the water, and that will push the cork open. The cork will open that way. Okay, very simple. Cork will open that way, the tube will go this side. That much only. You can see in the, when you try directly in front of you, this is a way to see without you have not touched anything. Given the fire, inside gas is accumulated. That gas is pushing the cork away. That is action. Action, you'll see the reactions. Okay, and when the cork is going off, this tube will get the recoil this side. So that much is the example of action and reaction. Okay, the activity 2.2 may not be very easy to show in the diagram, but I will try. Okay, this may be easy. This one is also used many 2.2 is also very popular, but if you have not seen, let us see. There is one stand, very firm, okay, on the ground, and there is one hook, okay, one thread here holding another, one person is here who is holding this thread, right? Understand? This is a thread, very fine thread, strong thread, and he's holding it very tight. Now I come with a balloon, okay, you understand? Balloon, you can hold it here with your hands. This person may hold this balloon here with his hand. Okay, the balloon is filled, and the important part is this one. There is a small pipe, straw, you know, lollipop straw, or slightly bigger, that fruity straw or something like that. You put inside this thread. The thread should be inside this straw. What will happen? It will slide. That means that this straw pipe can slide here. Very light one. It can slide here. It can go here and there. Okay. Now we put it like this. What you do here is you put a glue here, or you can put some sellotape also. You can use the sellotape on the balloon and the straw. Okay, this is straw, this is balloon. Now what you do is, this person will release this balloon is big now, inside there is lot of air. This will be released, just release. Then what you will see is air will come out of this, air will come out of this action. What do you expect? You'll expect that this will go this side, and in order to go here, you have the straw, it will take it here. And in the second diagram, what you will see is what you will see here is this balloon is inflated. This balloon is inflated. Okay, this balloon with that straw, it will go this way. Understand? What happened here is important. When he released the straw, when he released the balloon here, all the air will come out from this direction, giving this is the action force, and then the reaction will take it in this direction. So this is an example of, with every action there is equal and opposite reaction this way. Okay, this is also called balloon rocket, something like that. In the YouTube you can find it, balloon rocket, because children can just see in a funny way that a rocket like balloon is, when you release it, even in your hand also you can try, just fill the balloon and release it. What will happen? When you release the balloon, the air will come from this side, the balloon will move here, isn't it? If the balloon is very strong one, the tight one, the balloon will go a little far. That is what action, reaction. Release of the air is action, the going down away of the balloon is reaction force. That is what the activity 2.2 says.